We are solving ISS 2022 paper 2 question number 14. So we have given that let x1 is to xn be IID random variables from fx, and its PDF is given like this, and x is lies between 0 to 1 and theta is greater than minus 1. Then MBUE of theta is this. Okay, we need to find the MBUE of theta. So how do we find it? So we have given the following information. x1 x2 xn is following a density of x, which is given by theta plus 1 x to the power theta. X is like between 0 to 1 and theta is greater than minus 1. Now we need to find MBUE. So what is MBUE? So MBUE basically are the function of sufficient statistic which are unbiased. Okay, so we need to first find the sufficient statistic. So how to find sufficient statistic? Like the likelihood basically multiplication of their joint densities. So likelihood will be theta plus 1 to the power and multiplication of xi power theta. Now this is in terms of gtx comma theta and hx is 1. So by using factorization theorem, so multiplication of xi is our sufficient statistics. But now again use the invariance property of sufficient statistics. So if we take log of x, log of this, then that will also be a sufficient statistic. So take the log of this. So this will be I from 1 to n log of xi. Okay, so this will also be a sufficient statistic. But we also need to consider that x is lies between 0 to 1. If we take log of x, then log 1 will be 0, log 0 will be minus infinity. So log x is in negative. Okay, so it is better to consider negative of minus log xi instead of plus of log xi. It will be helpful for the calculation. Now minus से multiply करो यहाँ पे, so minus log x will be positive. So range of here minus log x is positive. Okay, so now what will be the distribution of minus of summation of log xi? So first find the distribution of log of xi. So x is following this, and assume y is minus log x. Now x will be e to the power minus y, and dx by dy will be e to the power minus y minus ka, but when we take the mod of, there will be this. Now fy will be fx dx by dy. So now what is fx? So fx is given this theta plus 1 x to the power theta. X is our e to the power minus y theta, and dx by dy is e to the power minus y. So theta plus 1 e to the power minus y theta plus 1, and y is following 0 to infinity. Y range is this. Now so y is following exponential distribution. So what is MHT is? MHT is given by 1 minus t by theta plus 1 minus 1. Now so y is basically our minus log of x. Okay, so we have given that x1 x2 xn following this, and minus of log x1, this is this minus of log xn following exponential distribution with mean 1 by theta plus 1. Okay, yeah, density is given like this. Now we know that the sum of exponential follow gamma distribution. Now so this is following exponential, so summation of log xi will follow a gamma distribution with parameter theta plus 1 comma n. Now we can see that from the actually that this is this. Now m of minus of summation log xi I from 1 to n t will follow because they are independent. Now summation will be, now we are using the MHT property. No, when x1 x2 are independent, then their sum of the moment generating function will be multiplication of their MHTs. So this will be I from 1 to n 1 minus t by theta plus 1 minus 1. This will be 1 minus t by theta plus 1 minus n. Okay, so distribution, so let's suppose this is t, mtt will be 1 minus t by theta plus 1 minus 1. So this is in terms of the moving generating function of the gamma distribution. That is what I'm saying here. Okay, so I just write it for better understanding here. Now so t is equal to minus summation of log xi will follow gamma distribution parameter theta plus 1 and n. Okay, now so t is equal to minus log of xi is following a gamma distribution with a comma lambda, where a is our theta plus 1 and lambda is n. Now so our objective is to find the MBUE of theta. MBUE of theta is basically the function of some sufficient statistics which is unbiased. Okay, now in the mean is given by the mean of gamma distribution parameter a comma lambda is given by lambda by a, which is n by theta plus 1. Now if you take the expectation, now here theta is in the denominator. Okay, so but we need to find the estimate MBUE for theta, so this won't work. Okay, so now we need to go on some another procedure. So how we go on that? So now look at the example. So option B cannot be MBUE of theta. Now we can see from the option A, C and D that summation of log xi is taken in the denominator. Okay, so I can get an idea that if I get if I take expectation of 1 by t, then I think I should get some in terms of theta in the numerator. Okay, so let's take this will be 1 by t. Now density is given by e to the power lambda, e to the power lambda, e to the power minus x means t, and x to the power n minus 1 divided by gamma n dt. So this is density. Now theta plus 1 to the power n will be outside and gamma n will be outside 0 to infinity. Now h to the power, this should be t. Now there is a t in the denominator, so this will go up, then this will be t to the power n minus 1 and this will be e to the power minus theta plus 1 t dt. Okay, now theta plus 1 to the power n gamma n. Now use the gamma function, so this will be gamma n minus 1 divided by theta plus 1 to the power n minus 1. Now this we can rewrite as n minus 1 gamma n minus 1. Okay, this gamma n minus 1 theta plus 1 to the power n, and minus 1 will be in the numerator. Now gamma n minus 1, gamma n will cut it out, this will cut it out, so we are left with theta plus 1 and minus 1. So this n minus 1 is a constant, so we can just n minus 1 t, and 1 we can like this. So when we take the expectation of 1 by t, we are getting theta in the numerator, and all other things we can put in the left hand side, so we are getting like this. So what is t over? What is t? This is minus of log of xi summation I from 1 to n minus 1. Okay, so this is we are getting what the MBUE of theta. So this is how this question should be now. So option A is correct.